Hey, everybody, let's take a look at Lagrange multipliers. So f of x, y is just our general function, and this is the function we want to maximize or minimize. We want to find the extrema of this function.
We got 3 people here and 3 people on Zoom.
Extrema of a function. In this case, f. I'm gonna use f to describe them here. But this function, like if I put this in the if I did x squared minus y squared, I could come up with what. Actually, let me do this a better way. Let's write this in 3D. So y and x, and so for each point x and y, this value has a function. I don't know what that surface is looking like. Let's see, maybe x squared minus y it's got to be a hyperbola. It's a hyperbola of some sort. But let's say in general, I don't want to sketch a 3D hyperbola. That sucks. We got some surface like that. And so there's extrema all over the place on this thing. But let's say on this surface, we want to constrain. We want to put a constraint on our system. Constraint on our surface. We want answers that only fit one equation. So like my G up there, if I use my G, I could rewrite G as x squared plus y squared minus 25 equals 0. And if I said that was Z, this would make another surface right here. It would make a cylinder. That one's easy to see. And so we're looking kind of like where on the black surface, because this black surface does not match the x squared minus y squared. Where on the black surface do we have extrema that intersect with the cylinder? That's the idea here. So like, I think I need to point out, this is not x squared minus y squared. The way we can do that is we can take the gradient of f and we can take the gradient of g, where g needs to be written like a level curve. G needs to be a level curve. Where the right side equals 0. So these are like contour lines on F. G has contour lines on F there. And if you watch the video, we derive showing, I got these far apart, that these should be parallel. And so there is some multiplier lambda that would make them equal. So gradient of F is parallel to gradient of G. So f of x, y covers everywhere. We want to constrain where we're checking for answers to a certain formula.
How does somebody get it?
So how do we do that? Let me slow down.
So what I don't understand is how the hell are we supposed to know this in chapter 13? It said
chapter 13, you're doing maxima and minima. Chapter 13 is on partial derivatives. All of that's You've covered all this stuff that's similar to this.
Hey, but we didn't know anything about the gradient,
Yeah, we did.
did we?
Yeah, we
Yeah.
did. It's partial derivative chapter. You knew about the gradient.
You guys did gradients in what,
Theoretically, you know,
basically after partials.
I thought it was chapter. Oh, shit, that was chapter.
14 was integrals, 13 was derivatives.
Okay.
It may seem awkward because I'm teaching it out of order. This is just a special example of finding an extrema.
Yeah, that's what it was. It was out of order. That's why.
Yeah, I'm blaming on that.
I didn't remember at all what we did.
So let's take the gradient of f. If we take the gradient of f, we get 2x and negative 2y. And it's a vector now. And if I do the gradient of g, I've got 2x and 2y. And we're going to multiply that by some scalar lambda. And now we want to look at, we want to match up our i's and we want to match up our j's, and we're going to have two equations. So one of them, I have 2x equals 2 lambda x. And the other one, I have negative 2y equals lambda 2y, 2 lambda y. So what I'm going to do is I'm going to make the right-hand side equal 0 by collecting everything on one side. I'm going to move this one over the other way, just because I want positive answers or positive terms when I can. And then I'm going to see how can I solve this. I could factor out a 2x on this one. And I've got 1 minus lambda equals 0. And over here, I could factor out a 2y. And I've got 1 plus lambda equals 0. 2y and 1 plus lambda equals 0. So this tells me x equals 0 or lambda equals 1. And this one over here is y equals 0 or lambda equals negative 1. Okay. So let's go ahead and check it in our constraints. The constraint is where we're limiting our stuff. If I plug in x, I'll start with the left one. We're going to do case A. Case A, x equals 0. I'm going to plug in g, x equals 0, and then y. Recall g was x squared plus y squared minus 25 equals 0. So if I plug in 0, I've got y squared minus 25 equals 0. Which means y is going to equal plus or minus 5 if I solve it. Okay, so I know x equals 0. One of the other options is y equals 0. This is not the case where y equals 0. Y does not equal 0 here. So this must be the case where lambda equals negative 1. So that's doing those. And that gives us 2 points, 0, 5, and 0, negative 5. Then we take a look at the lambda equals 1 case. Case B, if lambda equals 1, I can put that in the other equation, and I got 0 equals 2y times 1 plus 1. So I got 2 times 2, I got 4y equals 0. So y equals 0. That's clearly matching, that matches up with what we thought. And now I need to find out what x is, so I go back to my constraint. My constraint was the g of x, y. Here I got g of x and y equals 0. So here I've got x squared plus 0 squared minus 25 equals 0. And we're going to get x equals plus or minus 5. So for the lambda equals 1 case, our 2 points that we're looking at is going to be 5, 0, and negative 5. I wrote negative 0.
Was the green part just a check, or like what was the point of that?
The green part was to find out, we're trying to find x and y. And so like, if there's more than a bunch of options, like if we have like a bunch of different lambdas, we don't know what pairs up with what. And I was just verifying that lambda equals 1 pairs up with y equals 0. Here we only have 2 equations and 2 unknowns. The lambdas should pair up with the other variable. But when you have 3 equations with lambdas in different spots, 3 different lambdas, we need to check. We'll see that on another problem. So what we have now, we have 4 points. On the function f of x, y. We have 4 points on the function f of x, y that are extrema with the constraint that they lie on x squared plus y squared equals 25. So f of x, y is going to have more extrema than that, or can. And it's these 5 points, so we don't know whether they're maxes or mins. To figure out if they're maxes or mins, plug them in.
Sorry, that was G. X squared. Wait.
Plug into F.
What was the could you, oh, you got, okay, never mind.
And because F is the equation we are trying to maximize or minimize. So let's do that. The 4 points we have are 0 plus or minus 5 and plus or minus 5 comma 0. F, as a reminder, was x squared minus y squared. So plugging in either plus or minus version, if I plug in 0, 5, or 0, negative 5, F becomes zero squared minus 5 squared is negative 25. Minus plus or minus 5 squared, I should say. When we square it, it makes that positive 25 in both cases. So F's value is negative 25 there. And if I plug in 50 or negative 50, plus or minus 5 squared minus 0 squared is 25. So we have maxima at 50 and negative 50. And minima at 0, 5 and 0, negative 5. When we have those constraints. If the constraints change, this entire thing's change.
So is that just because it's a circle? That's why the maximums are there, or that's just coincidence?
It's because the value, one's negative and one's positive, so I know that they're already extremists. So they're either gonna have, they're either like this or like this. Which one? Whether or not they're concave up or concave down, I don't know, but I can tell one is larger than the other. So, and I know they are one of these, so this has got to be a max and this has got to be a min.
Right. Like I'm saying, like could you just draw like the sphere or a circle and just like see the maximums are there? Type of thing.
If you had the F sketched well, yes. Like, so, like, look at, oops.
Oh, okay.
So we've got this circle. And we just saw it lies on the axes. What if we tried 3, 4? On a circle of radius 5, there's a 3, 4 triangle. So if I tried x equals 3 and y equals 4, I have f of 3, 4 is 3 squared minus 4 squared. 9 minus 16 is negative 7. It's between these two mins and maxes. And the closer we get to one of the maxes along the x-axis, the closer we should be getting to positive 25. And it looks like the closer we get to the vertical axis, our y-axis, the closer we're getting to negative 25. Because 3, 4 is on that thing, so is 4, 3. And this only changes slightly. Well, the value changes a lot, but and I'm picking ones where I know that I can just do integers. We could find out what y is when x is 4.9. I mean, we could do the math using x squared plus y squared equals 25. Find out what y is, then plug them into f and go, what is it? And it's probably like 24 something, because it's got to be close to the 25.
So are we just essentially like laying that x squared minus y squared function on top of the circle and then using the circle's max and mins to like?
It's not the circle's max and mins. It's where the circle is maximized and minimized under that f. They go together. It has to be together. Because we found them using both equations. In fact, let's change this up. Let's
Here's a good example. So when
I
I learned
feel like the best way to do it is just plug deadlift and then graph it so I can see it like overlaid.
So a good example is that the way I learned Lagrange multipliers was first doing finding the maximum dimensions for a box for a certain volume, like the regular way, and then doing it with Lagrange multipliers. It severely limited the amount of area to do.
yeah, and I have that in the lecture videos. And I need
buddy.
I don't know that this, I'd rather do it in GeoGebra.
Damn.
Give it a try over there. GeoGebra doesn't always want to load for me though.
God damn, you guys sit through your tabs based on the icon or what?
Oh. Let's see. First.
Okay, put it in 7.
Oh.
Looks like a paddle. Bro sets it off again.
Yeah, GeoGebra hates me.
Well, right, my professor was hating you earlier as well.
I suppose you got about a fucking probably like 10 gigabytes of RAM to use up on all the Google Chrome tab.
What?
I said that's probably because you got about 10 gigabytes of RAM being used up on all those Google Chrome tabs.
It's shit I want open. I don't want to have to go looking it up again. All right, so I'm going to go back to what I was saying, and we'll see if GeoGebra loads in the background. If I change the function that it's on, like x squared plus y squared equals 25, if that's our constraint, if we change the function we're looking at, like maybe make it x minus, or x squared minus, oh, let's do like x minus 3 squared plus y plus 2 squared.
I looked at
And I still got g is x squared minus, or x squared plus y squared minus 25. If we redo this, this is going to have similar values. So here I have 2x, 2y for the gradient of f. And gradient of g is 2x, 2y. I wonder how this is going to work when they're both like this. We're going to have 2x equals 2 lambda x. I think I'm going to get the same shit. Let me make this, put a 2 in front. So this ends up being 4y. That'll change it. And I've got 4y equals 2 lambda y. So, and I didn't want to go all the way through this whole problem because I'm trying to show that using a different function gives us different values where the constraints lie. So 2x minus 2 lambda x equals 0. I can divide by 2, and I've got x times 1 minus lambda equals 0. If I do that over here, I've got 4y minus 2 lambda y equals 0. And I can divide by 2, and I can pull out a y, and I've got 2 minus lambda equals 0. So I get either x equals 0, lambda equals 1, or y equals 0, lambda equals 2. I'm going to focus on the y equals, let's do the y equals 0 first. I did x equals 0 first last time. We'll do y equals 0 first. If I plug in y equals 0 first, I've got g of x comma 0 is x squared minus 25 equals 0. So x equals plus, this might still be the same thing, just have different lambdas. So I've got values plus or minus 5 comma 0. Interesting. I think this is only affecting the lambda. It just changes the lambda value. which is not x equals 0. So this must be the lambda equals 1 case. So y equals 0 goes with lambda equals 1.
Why do you say that? Like, I thought the x equals 0 and the lambda equals 1 thing is like together. Or is that like not true?
No, we have a 0 product rule. So here, I mean, two things multiply together to equal 0. A equals 0 or B equals 0. So these don't happen at the same time. It's either one or the other. I mean, they could happen at the same time. But these both equations need to be solved. And so when I do y equals 0, I don't get x equals 0. So y equals 0 must be the lambda equals 1 over on that equation. And if we do that, maybe I am doing this through all the whole way because it might change the answers. And then we do the we do the x equals 0 case. And we get y equals plus or minus 5. Just like we did before, lambda is going to be the lambda that makes lambda equal 2. We get this by plugging it into 0 or g. So I get the 0.0 plus or minus 5. Those are still our extrema, but which one's which? We got to check in our f. So let's check in f. F of xy was x minus 3 squared plus 2 times y plus 2 squared. Now I can't just race through them. I got to do them individually. Let's do 0, 5. If I do 0, 5, I got negative 3 squared plus 2 times 5 plus 2 squared. This is 9 plus 7 squared is 49 times 2 is 98. So this ends up being 107. If I do 0, negative 5, still got negative 3 squared. I've got 2 times negative 5 plus 2 squared. This is 9 plus negative 3 squared is 9 times 2 is 18. This is 27. Now they're not, notice these are different values now. 0, 5 and 0, negative 5 don't have the same value like we did in the previous problem. So the function f very much says whether or not they're maximum or minimum. If we do the 5, 0 and negative 5, 0, 5 minus 3 squared plus 2 times 2 squared. I've got 2 squared is 4 plus 8 is 12. Plugging in negative 5, 0. Negative 5 minus 3 is negative 8. Squared is 64. Plus 8 is 72. So now my max is at 0, 5. My min is at 5, 0. And that's different than what, oh shit, I just bumped my camera, sorry. That's different than what we had before. So the G didn't change here. The only thing that changed between those two problems was F. So I was trying to illustrate that it's both things together. We have some function F that's good everywhere. G is constrained though. It's got something that limits where it's at. So G is acting like a constraint on F. We can do an example like Brandon was talking about. We'll do a box problem. I'll just make that shit up right now. We're gonna make that shit up right now.
That can only go well.
Imaginary numbers.
Well, actually, you got an imaginary number and you answered our problem as well. I don't remember why. There's a good reason for it though.
Box company. Yes.
So let's do the volume of a box. And we want to maximize the volume of a box. Let's say,
Would you rather maximize the
this
volume of
might
the
be
sphere?
ugly because they did the problem in the video.
Well, let's maximize the shape of something crazy. I don't know.
In an amorphosis, or like a shape that's not really very defined.
What is that one shape that doesn't ever end and it only has like this one?
Okay.
Maybe, I think I'm thinking of that one that like twists on itself. It's like only has one surface. For the monkey stand. Yeah, let's maximize that.
So we're gonna do the volume of a box. So we're gonna maximize the volume, not
Can't
maximize
really
the box.
define it.
Maximize the volume given that the surface area is 100 inches squared.
Why don't we
And
do
this will be
something
all
crazy?
surface.
Why don't we do
What?
something crazy? Maximize the volume of claim. Why don't we do something crazy? Like we always do a box or a square. It's always like some lame shape.
You don't even know how to do these in general. Why do we gotta do something crazy when you're just learning to walk? This won't be crazy enough, I promise you. Volume equals length times width times height. Surface area, if we draw the box, and let me do a better box. Let's call this L, W, and H.
I don't know if that.
The surface area, I've got two sides that are L times H. I've got two sides that are L times W. And I've got two sides that are H times W. And that needs to equal 100 inches squared, but we'll add the units in later. Like, you don't think this is going to be crazy. This is already going to be crazy. So this surface area problem we're doing is our constraint. We're constraining, because the box could be any size, so the volume could be any size, but this is acting as a constraint on volume. So this is my G. And this is the objective function that we are trying to maximize or minimize. I'll call that F. So we're going to do the gradient of F needs to equal lambda times the gradient of G. The gradient of F is, let's put them in the order I have them, L, W, and H. So I've got WH, LH, and LW. And on the right side, we got lambda times, we're doing the derivative with respect to L first. I've got 2H plus 2W. And then I'm doing respect to W, I've got 2L plus 2H. And then I'm doing H is going to give me 2L plus 2W. So this is going to be shitty. I don't know that this was a good example to go to next, but you wanted to see something that you can actually visualize in your head a little bit better.
Yeah.
We got to pair these up. So WH equals 2 lambda H plus 2 lambda W. And we do the next one. I've got LH equals 2 lambda L plus 2 lambda H. And I finally do the last one. I've got LW equals 2 lambda L plus 2 lambda W. So lambda, I don't know. This is going to be easy this way. What can I do with this?
Everything's nice to get rid of that height.
Well, I can go.
Second.
Because we need to kind of solve these all together. So I guess I could go factor out at 2 lambda on each of them. WH equals 2 lambda times H plus W. So that 2 lambda equals WH over H plus W. And if I do that here, I've got LH plus, or LH equals 2 lambda times L plus H. So 2 lambda equals LH over LW, or L plus W. And I could set these equal to each other. This is ugly because I went with a difficult problem. Well, I've got H on both sides, so I'm going to eliminate one of the H's. So I've got W times L plus W equals L times H plus W. And then I could do the third equation. If I bring in the third equation, I should get a 2 lambda. If I'm following the pattern, 2 lambda is the LW over L plus W. So I could equate this to something, one of the other ones. I did the top two. Let's do the middle two. I'll put these two together. Not those two, these two together. And I've got LH. I wish I had not listened to fucking Brandon and done a box.
Yeah, I didn't say it was easy. I just said that's what we did.
The box was easy. In the video, it's easy because we had the sum of the dimensions was 96. But that's not really practical. Why would a business do that? A business would try to use a certain amount of surface area per box. That would matter because that's
This
constraint.
is far more relevant because your volume could probably be like is a constraint that is usually like, say you have something that you need to fit into something that can only be a certain volume, but you need to maximize that size to maximize the amount of profit you make. It's like a can of soda.
Should have been an H right there.
You want to see?
which
This is our
was,
box problem.
which was that one right there,
And this is
which
the
is
box
that
problem.
one right
But that
there,
one-
which is that one right there.
No, it's a lot of algebra. Huh? That was on mine. You guys didn't, it's not as,
We didn't use the Lagrange multiplier. We didn't have that.
no, you guys didn't, because he didn't require it for the final. Right.
So here I can cancel out an L and I've got H over L plus H equals W over L plus W.
Right on that one.
I think that's what most everybody else here did.
Everybody else, everybody's not here.
You know, I'm saying the same thing, but these are also the regulars. You guys are also the regulars, so.
And notice I have,
Or Jericho. Richard's appeal, so united.
so I have this and this, which means these two have to match up. H times L plus W has to equal L times H plus W.
Welcome to the matrix.
I'd be pissed off if my brain read that something like Jericho.
Again, I would literally sit in my brain if that was the case.
Got it by with your brain.
We're almost there, believe it or not, because the LH is canceled
And we're through a room yesterday talking to nobody.
and I get HW equals LW, so H must equal L.
People want to feel about this, let them follow my lead.
They'll call it yours.
Yeah. People want, please,
No, when you say let them follow my lead, that means like you're the one leading that, like you're the one giving up and they follow that.
I lead them.
And we plug this in up here.
I see what you mean, but no, that's not what that means. When you say follow my lead, it's like you're doing something, so then we're supposed to like repeat it.
So I've got
Oh.
W equal, or W times,
Oh, my
I'll
word.
I'll replace the H's with L's. L plus L equals L times L plus W.
I will be honest, I thought you were about to say
So-
alpha ratio.
2LW equals L squared plus LW. So I subtract LW and I've got LW equals L squared. Divide by an L because it's not zero. We have a box and we get W equals L. And so L equals W, L equals H, so H equals W as well. All three equal each other. And we knew, yeah, like if you've done enough calculus problems, you know that the best box is a cube. So this isn't a big shock. We've got L equals W equals H. And now we just got to find out what that value is. I need to clear a board.
Right.
We're going back to the constraint function. Two LH plus two LW plus two HW equals 100. Let's just make them all L's. They all equal each other. So I've got 2L squared plus 2L squared plus 2L squared equals 100. So 6L squared equals 100. I'm running out of time is why I'm going a little bit faster. L squared equals 100 over 6. So L is 10 over square root of 6 or 10 root 6 over 6, which is 5 root 6 over 3. And that means that's the value of H and W as well. And the volume is maximized when we multiply those all together. L times W times H, 5√6/3 cubed. Inches cubed, because it was in inches. And pulling out a calculator, just because I'm kind of curious. 10 divided by √6. And now cube that motherfucker. Not very big. 68.04 cubic inches. So if we want to do surface area, if the surface area of the material is only 100 square inches, the maximum volume occurs at 68.04. This was not a trivial problem as much as Lawrence thought it might be when we started doing the volume of a box. This was some ugly ass algebra, but we were able to solve it with enough persistence.
And if you do it without Lagrange multipliers, it's even more algebra.
It's all just addition.
Right, the Lagrange multipliers help speed it up.
Yeah.
Yeah, make a class. That's it. Like
Watch that here on the final.
Oh, I better not.
It's actually we're gonna use the Lagrange multiplier. Does everybody know what that is? You know what that is, right?
It's not a very big box. 10 over square root of 6 is 4.08. So it's not a very big box, a 4-inch, a little over 4 inches on the side. Ends up being 100 cubic inches or square inches going over every surface. That's kind of crazy. And that will be it. Tuesday, not Tuesday, next week's finals. Our final is scheduled for Thursday. So I will be holding stuff over Zoom. You don't have to come to campus for a class you're not taking a test on. I'll have stuff up for centroids, and we can take a look at.
It's a Zoom class. It's gonna be next Thursday. It's gonna be Zoom, right?
Yeah, next Thursday's Zoom. So you don't need to come to class. We'll just do it on Zoom.
Nothing happened on campus. Most of all, I'm not gonna be sure on campus.
Not one showed up in the Zoom.
So
Yeah. I'm done anyway. And then I just turned on and stopped paying attention.
Alright.
yeah,
Tell me right here.
I turned it on and continued about my morning stuff. I was like, oh, I'm gonna go hey, slept on the background. I just hear Jealous talking in my room.
the tech connect.
Lawrence,
That's what
what time do you?
Yeah.
It's actually on Zoom, guys. And they just get on there and just like fuck off and do something else.
Yeah, very sudden.
Lawrence.
Yeah.
Should be able to go in
What
there.
are you thinking about for Monday or Tuesday?
Oh yeah.
Worst case scenario, we can always like.
I just couldn't go Saturday because of that thing, but yeah.
Right.
Worst case
But I
scenario, we
can
could
help
just
you
send like a Zoom link through the Discord or something.
Yeah, I'm down Monday and Tuesday.
What time works?
Oh, what time?
Yeah.
Morning's fine with me.
Okay, I'll be there. I'll be at Starbucks at 7 on Monday.
See the bear.
I'll put it on Discord.
Fair study this.
What?
Oh, we're going to the Griffith Observatory
The observatory?
in Los Angeles.
What?
It's that big ass observatory.
Next week?
Oh,
That's like tomorrow.
Yeah, why
Well,
would you guys
no.
plan a fucking field trip the weekend right before finals?
You're
That
not
was like
ready
the-
for finals the weekend before, then that extra day is
That's
gonna
your
help.
last
Yeah,
chance to
that's
study.
Why? Let's
Go to the fucking observatory the week after finals.
Because no one's
That
gonna be
would have
here-
been the smart thing to do.
no one's gonna be here the week after finals. Everyone's gonna go
Y'all
about
ain't
their
doing
life.
nothing. Everybody could have gone easily and not worried, not gone. I should have been studying for finals. That's just me. If I don't see you guys on Thursday, have a great semester. Do well on your finals, and it's been a pleasure teaching you.
All right, thank you so much.
Thank you guys for coming.
And James, I hope I get to kick your ass in circuits next semester.
Sure.
Slow down.
All right. If there's no extra.